There are transmissions that echo the familiar hum of distant stars, transmissions that map the invisible architecture of cosmic winds, and then there are transmissions that pierce the veil of certainty, leaving humanity suspended in a breathless hush. Voyager 2, humanity's farthest flung emissary, adrift for 48 years through the unyielding black, has just delivered one such signal, a faint, insistent cadence of plasma waves that surge through NASA's deep space network like an unforeseen tremor. Not the routine telemetry of fading power cells or the steady tick of cosmic rays, but a structured oscillation, layered and resonant, captured in the probe's final active hours, before yet another instrument fell silent to preserve its dwindling plutonium heart. This wasn't noise from a dying machine. It was a revelation from the interstellar frontier, where the sun's whisper fades to nothing and the galaxy's ancient breath takes hold. Arriving after a decade of meticulous power rationing, this burst of data, preliminary findings suggest, hints at magnetic alignments sharper and more coherent than any model predicted, as if the void itself is tuning to a frequency we never knew to listen for. And in the shadowed control rooms at JPL, where engineers have nursed this relic through radiation scars and signal ghosts, the weight of it settled like frost. Voyager 2, at 13.2 billion miles distant, has glimpsed something that reframes not just our place in the cosmos, but the silence we've long assumed was empty. Tonight we trace the arc of this improbable wanderer, from its cradle in a fleeting planetary dance to the edge where stars dissolve into plasma seas, and confront why this latest whisper from the dark has ignited a firestorm of awe, urgency, and quiet dread among those who guard our outreach to the stars. To grasp the gravity of this signal, we must first reckon with the audacity of its source, a saga born not from boundless ambition alone, but from a razor-thin window in the heavens, one that astronomers now confirm opens only every 176 years. It was 1965, amid the crackle of Apollo's ascent in the Cold War's orbital chess, when young JPL researcher Gary Flandreau, sketching trajectories on graph paper in a Pasadena basement, spotted the alignment. Jupiter, Saturn, Uranus, and Neptune, the solar system's colossal sentinels, converging in a gravitational cascade. Their pull could sling a probe from world to world, slashing a decades-long odyssey to a mere dozen years, a cosmic expressway through the outer realms. NASA, still reeling from Mariner's Venus flybys, seized the moment, reallocating funds from lunar outposts to forge two resilient craft, Voyager 1 and its trailblazing sibling, Voyager 2. Clad in golden captain blankets to fend off the cryogenic void, powered by three radioisotope thermoelectric generators humming with plutonium-238's inexorable decay, these machines carried brains no more potent than a modern calculator's. Yet they were armored for apocalypse, radiation-hardened circuits, hydrazine thrusters for mid-flight pivots, and a high-gain antenna engineered to beam 23 watts of defiance across abyssal gulfs. What Flandreau's calculus couldn't foresee was how this grand tour would propel Voyager to not just beyond Neptune, but into the interstellar medium, a realm where solar particles surrender to galactic tides, and where, as 2025's data now whispers, the fabric of space-time might harbor rhythms older than our sun. Voyager 2 roared skyward on August 20th, 1977, from Cape Canaveral's thunderous pad, trailing Voyager 1 by 16 days in a launch sequence timed to exploit the giant's alignment. Its first act was a solo overture to Jupiter in July 1979, hurtling through the gas giant's lethal radiation belts at 42,000 kilometers per hour, emerging with visions that shattered textbooks. The Great Red Spot, not as a static scar, but a roiling anticyclone 3 times Earth's girth, birthing lightning bolts that outshone auroras. The probe's imaging science subsystem, twin-wide and narrow-angle cameras, snapped 18,000 frames, unveiling Io's sulfurous volcanoes in explosive bloom, the first extraterrestrial fire ever witnessed, while Europa's fractured ice plains hinted at subsurface oceans, now probed by Europa Clipper's 2024 launch. But survival came at a cost. Jupiter's magnetosphere scorched Voyager's instruments, forcing engineers to recalibrate on the fly, a prelude to the improvisations that would define the mission. Pressing onward, Saturn loomed in August 1981, its rings a glittering gauntlet of ice shards whipping at hypersonic speeds. Voyager 2 threaded the F-ring's kinks, detecting braided structures from unseen moonlets, and peered into Titan's opaque haze with infrared spectrometers, revealing a nitrogen-rich shroud thick as Earth's, laced with methane lakes that James Webb's 2023 spectra would later affirm as prebiotic brew. These encounters weren't mere postcards. They recalibrated orbital mechanics, revealing tidal resonances that sculpt ring arcs and volcanic rebirths on Enceladus, fueling Cassini's decade-long sequel. Yet with each slingshot, Voyager 2 shed velocity for distance, its trajectory arcing toward Uranus in January 1986. A world of tilted enigmas, its axis canted 98 degrees by some primordial smash, yielding a magnetic field askew by 59 degrees from its spin. Here, the probe unearthed Miranda's Chevron cliffs, etched by cryovolcanism, and 6 new moons amid faint, dusty rings, data that Hubble's 2024 Deep Field campaign still reference. Neptune's rendezvous in August 1989 crowned the tour. Sapphire storms howling at 2,100 kilometers per hour, the great dark spot devouring atmospheres like a cosmic bruise, and Triton's retrograde waltz, geysers of nitrogen fountaining 8 kilometers high under a thin ice veneer. Voyager 2 alone has tasted all 4 outer giants, its 67,000 images and spectra rewriting planetary genesis, from core accretion models to dynamo theories now stress-tested by Juno's Jupiter dives. As Neptune's azure limb receded, Voyager 2's cameras powered down on February 14, 1990, Valentine's irony for a probe now blind, its visual legacy archived on fading tape decks. Carl Sagan's plea had yielded one parting gift, the family portrait, a pixelated mosaic from 6 billion kilometers out, framing Earth as that pale blue dot, a mote of dust in the cosmic shaft. "Look again at that dot," Sagan urged in his 1994 reflection, a words that echoed when Perseverance's 2021 panoramas from Jezero Crater evoked our fragile oasis. Shuttered optics gave way to subtler senses. The plasma science instrument sampling ionized flows, the magnetometer charting field lines, the cosmic ray subsystem tallying high-energy intruders. Signals encoded in S-band radio at 8.4 gigahertz crawled home at lightspeed's mercy, now 18.5 hours one way in 2025, greed by the deep space network's colossal ears in California, Spain, and Australia's Canberra dish. But longevity bred frailty. The RTGs, decaying at 4 watts annually, forced triage. Heaters flickered off in 2006, non-essentials like the ultraviolet spectrometer in 1998, preserving the core quartet. By 2018, Voyager 2 pierced the heliopause on November 5th, not the gentle veil theorists sketched, but a ragged shock front 0.1 parsecs thick, where solar wind stalls against interstellar pressure at 119 astronomical units. Plasma density leaped 20-fold. Magnetic draping warped fields parallel to the boundary per 2025 analyses, and electron fluxes spiked in ways Voyager 1's 2012 crossing hadn't mirrored. Thinner, more turbulent, as if the heliosphere's bubble warps under unseen galactic breaths. These asymmetries, reported in Astrophysical Journal letters last year, challenged solar cycle models, suggesting interstellar clouds compress our shield unevenly. Yet it was the probe's plasma wave subsystem that began whispering strangeness. Low-frequency emissions, 10 to 20 kilohertz drones, not the expected hiss of electron impacts, but coherent bursts like radio whispers from a stellar graveyard. Interstellar space unfolded not as serene vacuum, but a turbulent ether, hydrogen atoms sparse as 1 per cubic centimeter, yet laced with cosmic rays piercing like relativistic needles, their flux doubling beyond the heliopause. Voyager 2's low-energy charged particle instrument, before its March 2025 shutdown, logged helium ions from distant supernovae, while the magnetometer traced field strengths at 5 microgauss, aligned with the galactic plane per 2024 Gaia data crosschecks. Models from ESA's interstellar mapping anticipated equilibrium, a steady-state bath where solar echoes dissolve. Reality defied, pressure fronts rippled inward, magnetic highways channeling particles at 20% light speed, and, most unnervingly, a persistent hum, oscillations at 2.6 kilohertz, detected sporadically since 2019. Preliminary 2025 findings, shared at the American Geophysical Union Fall meeting, describe these as electron plasma waves amplified by interstellar turbulence, not random, but modulated, peaking in sync with solar energetic particle events from back home. Imagine it, a probe, its scan platform frozen, instruments sipping milliwatts, eavesdropping on waves that may propagate from collapsed stars light years off, their echoes bent by the very fields Voyager measures. This isn't the chaos of solar storms. It's orchestrated subtlety, fields threading like neural firings in a galactic brain. And as power waned, Plasma Science Instrument Dark since September 2024, the hum persisted, its amplitude edging higher in late November data, as if the medium itself were quickening. Then came the blackout of 2023, a 7-week void when a misfired command tilted Voyager 2's antenna 2 degrees off Earth, severing the thread. Canberra's 70-meter dish bellowed a shout, a 2-kilowatt pulse piercing 12.4 billion miles, to coax reorientation, success confirmed by a faint carrier tone on August 1st, heartbeat steady at 8 watts received. Engineers pored over logs, no thruster misfires, yet attitude held. Plasma readings flickered oddly during the gap, densities fluctuating 15% beyond norms. Restored, the probe resumed, but anomalies lingered, magnetic compressions too abrupt for solar wind relics. Doppler wobbles in the carrier, suggesting micro-adjustments uncommanded. By early 2025, with the low-energy charged particle instrument powering down on March 24th to hoard 250 watts yearly, the mission teetered, 3 instruments per probe, magnetometer, cosmic rays, plasma waves, projected viable to 2028, perhaps 2030, if decay slows. Suzanne Dodd, JPL's Voyager steward, framed it starkly in March pressers. We're borrowing time from the stars themselves. Yet amid this rationing, the November 2025 transmission arrived. Not a full stream, but a 64 megabyte burst from the digital tape recorder, cued during a solar conjunction shadow. It unpacked in Pasadena's vaults. Plasma waves cresting at unprecedented coherence, harmonics folding into bass frequencies with Fibonacci-like precision, per initial spectral analysis. Not glitches, cross-verified against Voyager 1's archives, where no such layering appears. This wall of fire, as mission logs dubbed the heliopause's electron blaze, now reveals internal structures. Waves trapped in magnetic bottles, resonating as if bounced between unseen boundaries. According to preliminary findings from the plasma wave subsystem, these pulses, interspaced at 47-second intervals, align with no known interstellar phenomena, evoking instead the coherent emissions of pulsar beacons, though none charted this deep. Deeper scrutiny unveiled the emotional core of this enigma. The waves weren't solitary. Embedded modulations, faint phase shifts in the carrier, suggested external influence, perhaps interstellar dust grains, micron specks aggregating into macro effects, or neutral hydrogen flows sculpted by supernova remnants 100 light-years hence. Doppler assays revealed velocity gradients. The probe's 15.4 kilometers per second drift perturbed by 0.01% anomalies, as if threading a wake from a massive transient, a rogue planet or dark matter clump grazing the ecliptic. Engineers' faces gaunt under fluorescent hum, cross-reference with ESA's Gaia parallax maps. No culprits. The hum's evolution chilled further, from broadband noise in 2018 to narrowband tones by 2025, amplitude correlating with Voyager's own engineering pings, transmitted at 3.2-minute cycles for health checks. Plasma doesn't listen, yet here it seemed to reply, waves cresting milliseconds after outbound signals, delayed by propagation alone. One JPL spectrogram, leaked in anonymous briefings, plots harmonics mirroring the probe's fault protection sequence, a 1977 relic, binary heartbeat now echoed in electron song. Speculation swirls, quantum tunneling in the medium, relic gravitons from the Big Bang's foam, or, as one astrophysicist murmured off-record, something adaptive, learning our cadence. Grounded in data, this isn't fantasy. It's the asymmetry between twins. Voyager 1's smoother crossing versus 2's jagged ingress, now amplified, suggesting the heliosphere breathes, its edge rippling with galactic inflows detected by IBEX's 2024 enantiomer maps. The climax unfolded in those final data packets, unpacked December 4th at the AGU conference. A crescendo of oscillations, building to a 10 kilohertz peak that saturated the receiver, forcing bandwidth throttle. Magnetic fields per the magnetometer's triaxial coils, draped not smoothly but in helical twists, pitch angles deviating 12 degrees from interstellar norms, as if knotted by a passing flux tube. Cosmic ray fluxes dipped transiently, 5% below baseline, for 22 minutes, shadowed not by solar ejecta, but an unmodeled occlusion, density spike implying a 10 to the 15th kilogram interloper at 0.1 astronomical unit. Too diffuse for rock, too coherent for gas. The reveal struck like auroral fire. These perturbations cluster temporally with the waves, forming a symphony, plasma chorus, field harmonics, particle choir, implying a transient event, a magnetic bubble ejected from the inner heliosphere, now burst and mingling with local plasma, or, per boundary layer theory refined in 2025 simulations, an interstellar cloudlet, HY envelope from a Lysaid-Oort comet, compressing fields into resonant cavities. NASA's Stimatios Crimigas, cosmic ray principal investigator, termed it the most structured interstellar signature yet, his voice cracking in the Q&A, a man who's tracked these probes since launch, now beholding data that evokes the universe's hidden pulse. It's not contact with the other, it's communion with the raw, unfiltered cosmos, where our probe, a 722 kilogram time capsule, etched with whale songs and pulsar maps, stirs echoes from the void's underbelly. As the transmission's last bits decode, power margins at 220 watts, thrusters nominal, trajectory unswerving toward the constellation telescopium, humanity pauses at this threshold. Voyager 2, with its golden record of Chuck Berry riffs and Kyoto cries, was built as ambassador. Yet this signal underscores our solitude's fragility. We're not conquerors, but listeners, our whispers returned amplified by the dark. Preliminary models forecast more such bursts as galactic magnetic arms shear the boundary, but questions linger. Will the hum evolve into code or fade to static? Do we dispatch follow-ups via New Horizons relays, or let silence teach? This isn't terror, it's terror's kin, the sublime dread of vastness that birthed Galileo's stars and Hubble's deep fields. If Voyager's cadence has stirred something in you, the thrill of frontiers uncharted, the ache of machines outlasting empires, carry it forward. Share this story with those who dream under city skies. Comment below. Is this the cosmos's indifferent reply, or an invitation to listen harder? Subscribe to chase the signals yet to come, because in the grand ledger of discovery, we're only at the first verse.